Okay, so I just want to take a couple minutes to quickly review the activity in the lesson on scatterplots. So I gave you guys the data based on Italy, and I gave you that graph. I've got the graph somewhat set up here. I just wanted to kind of review how to do some of the things as well when you're setting up. I'm only showing the moving average here just because it shows the relationship a little bit better and it gets rid of the like day-to-day discrepancies, low case rates on weekends, and things like that. So first of all, from what I've got on the graph, I'm missing my axes labels. So we go into customize and we can add all of those things, titles and axes. So this is COVID cases versus time. And then if we want to set our horizontal axis, this is time in days since the, is it 10th case? 50th case? Put 10th, but if it was 50th, you guys still kind of get the idea. The reason I didn't pick like since first case is just because there's a lot of variability at the very beginning of the epidemic in certain regions. And then if we look at vertical, this is, no, it's not number of cases. This is kind of reproduction, growth rate is what we called it. Growth rate as a percent. Again, so we can see that the growth rate is declining over time, so that is excellent. The other things we can kind of take a look at that kind of connect to grade 9 type stuff. So you can see that I've added the trend line. So again, to do that, you went into series and you went add trend line. I tend to like to increase my opacity a little bit because it's a little low. But anyways, and when we add the trend line, if I add it linear, which is what we've done here, then it creates a linear model, predicting that the relationship is going to continue to be linear. And it gives us the equation of the line on the top if we select that as our label. So referring back to grade 9, equation of a line, y equals mx plus b. Y here is whatever is on your y-axis. In this case, it's representing it as a blue dot, which isn't the greatest, but that's okay. So that's growth rate equals, this is our slope. So in this case, it's 0.921 or 0.9. And it's negative, so that means growth rate is going down at about a rate of 1% per day, just a little under 1% per day it's going down. So it's going down very slowly. Again, this is the Italy case here. And even though it's going down quite slowly, it's going down fairly consistently, and we'll get consistently, and we'll get to that in a second. But the other thing I want to look at is the y-intercept. The y-intercept tells you where the relationship started in terms of its y-axis or its y variable. So in this case there, the model estimates that it started at 44%, which is kind of weird because because this is graphing since 10. So that's a little weird for my scale. I didn't notice that when I set that guy up. So if we want to change our scales, chart and axis series, horizontal axis, there we go. We want to set our minimum to 0. That's a little better. Okay. But I've started graphing only the data since the 10th day. So we didn't actually graph any data back here. Again, it's really variable. But it shows that the growth rate was estimated to begin at around 41%. Now you can see based on the actual trend that it was probably actually higher because it actually reduced quite quickly at the beginning. As soon as they started catching cases and started initiating some lockdown procedures or some public education about what was going on and all that kind of thing, the growth rate actually drops off fairly quickly if you do it correctly, which is great. That's what we want. We can also see now looking at the consistency in which it is going down. So that's where the R squared value comes in. So the R squared value is the coefficient of determination, which is just the squared value for the correlation coefficient. And correlation coefficient just says how well something is related. The big difference is that R squared is going to always be positive, whereas if we were showing an R value for this, it would be negative because our slope is negative. But both of them would be fairly close to 1 because this is a fairly strong model to our data points, or at least it is within kind of this area, which makes our value quite high. You can see that it does kind of come off our model at the beginning and at the end. Okay, so now we can also compare this to some of the other ones that you guys looked at a little bit. I was kind of disappointed by the number of people that actually submitted this activity. I was hoping that everyone was going to participate in the lessons because that is the expectation. So please make sure you're doing that in the future and actually submitting stuff. Then we have some more things to talk about going forward. So if we wanted to add New York, Ontario, Poland, and Germany, I was excited when somebody did Poland because that was a completely different one that I didn't have. So they went and found their own data as opposed to just adding on the data to update the lists. If we want to add more things, so this is where our X values are coming from. Everything in the B column. And then series, so far we have the D values. So that's where Italy is. To add New York, we're just going to add the C values. And it's going from C2 to C41. Even if it ends earlier, you want to continue it down to how far your X values are going down to, or else it'll say that there's a mismatch. So now we've added the red values in there for C, and you can see New York struggled at the beginning. Its growth rate increased quite rapidly, but then it kind of got it all under control. It's very difficult to lock down a city that size. And they didn't kind of implement the correct stuff really quickly. So that's why they kind of had a really bad effect. Also, just based on their size and their density, like it was pretty hard to not have a bad thing occur there once it got there. Okay, if we add Ontario, E2 to E4001. Ontario, here you can see at least we are finally going down in the right direction. When I was tracking it, we were still kind of on this little upward trend in the middle here. So now we're getting more on the downward trajectory, which is good. And again, this is when you guys submitted that. So that was a week ago that you did. So hopefully that's even better now. I'm pretty sure it is because I've been kind of following the data pretty closely. And then if we add in Poland, I have not been following them. So let's take a look at what they've been up to. Poland's been doing very good. Again, straight downward. It looks pretty linear and pretty consistent. Once we start adding on the trend lines, we can add that in and take a look at their correlation as well. Germany. Germany just popped in as orange, so it's kind of following through. You'll notice they're all sort of following the same slope. So similar slope means that they are decreasing at the same rate per day. So again, Ontario was about going down 1% per day. The other ones are pretty parallel, except for maybe Ontario, us. Although we're kind of parallel now in that last little bit, but overall, I would not say we're parallel. So if we did our trend line, and we were the third one down, we're E. So if I select the E series, sorry, go over to customize, go into series, and then if I go to the orange and add a trend line and display my relationship and show my R value. So you can see our correlation coefficient, or coefficient of determination, it's the squared of that, is quite low. So the reason it's quite low is because we kind of went down and then we were going up for a little while, which wasn't good. It wasn't a steep incline. It's still not the right direction you want to have. And then we kind of got ourselves on track and we started going back down. So it's not quite following as consistent of a linear model as the other ones. You can also see our slope is much less, again, because it's kind of going up and down. So averaging overall, it doesn't have as strong as a slope. We did, however, have a much lower y-intercept, which means we started doing things before we really even got a high growth rate, which is good news for us. The other sets of series would show kind of similar stuff to that. So again, the slope will tell you the change in one variable with respect to the other. So in this case, change in growth rate with respect to time. The y-intercept tells you kind of the initial value where your y variable started at 0 for the x variable. And your coefficient of determination or coefficient of correlation will show you how strong that linear model is. Now, we can do other types of modeling as well, right? So, especially for Italy here, maybe we want to go and look and see, okay, well, what if we made this exponential? So we just did exponential, and so I did exponential for Ontario. Sorry, let me go pick Italy again. Now let me switch that one to exponential. So you can actually see that one follows the trend a lot more. We can find an R-squared value for non-linear relationships. The correlation coefficient doesn't make quite as much sense, but people use the coefficient of determination a lot when you're talking about non-linear. So that's something as well to kind of think about. Again, big idea is the closer it is to 1, the closer your line or curve follows your dots, or the closer your dots follow your line or curve, I suppose. So that's kind of what you want to be looking for. Okay, and depending on what it is you're modeling, you should be thinking about, okay, why does this particular function make sense to model this relationship? So exponential functions make sense to model epidemiological responses because that's how the actual virus can grow or shrink, right? Because it's exponential, because one person can affect multiple people. Those multiple people then infect multiple people, so it grows exponentially. So that's why it follows that exponential curve. I just wanted to show you kind of looking at a linear model just to review the particular pieces of linear models. And because over a short period of time, we can do a pretty good linear model to those particular pieces. So that was good to do. Okay, hopefully that kind of reviews some of that stuff for you and you're a little more cleared up if you were a little lost on any of that stuff. Again, a lot of it is review of grade 9. Now it's just kind of applying it into Google Sheets, and then it's adding in that correlation coefficient slash coefficient of determination. Again, if you want to do any of this using functions, if I just want to get the slope, maybe I didn't want to make a graph, I could just type equals slope, and then I can select my y value first, which is weird because usually you put your x values first, but it wants your y values first. So like if we were doing Ontario, I'd put Ontario. And then my x values. And that would get me that particular piece. Okay, if I wanted to find my intercept, then I'm just going to type intercept. Again, that's going to give me my y-intercept, even though it doesn't say the y part. Again, I'm selecting my y coordinates, then my x coordinates. If I want to find my correlation coefficient, I'm just going to type Correll. Select my y values, select my x values. You can see my correlation coefficient was 0.7. My coefficient of determination would be that squared. Okay, that is it.